In this session, we are going to discuss the practical approach on the linear regression in the machine learning. Okay, so the implementation of the simple linear regressor with the single neuron model that we are going to discuss. Okay, so the prerequisite is what? That is the basic of Python as well as the data mining algorithms so that are required, and the software requirement is Anaconda package with the Python 3.7. So basically, what is a linear regression? Why that is important in the machine learning? Machine learning, basically there are two types that we know: the supervised machine learning and unsupervised machine learning. The supervised machine learning, it has a various algorithms like a regression and the classification. So the linear regression is one of them. So the linear regression, basically it is analysis that is used in the statistics to find the trends in the data. So basically in a various business, various marketing trends. So these can be determined by the regression analysis nowadays. So for example, you might guess there is a connection between how much you eat and how much you weight. So that regression can analysis help you to quantify that. So means in every example where is a trend that we need to determine, there is a regression analysis that we need to find out. So, in the mathematical terms, what is a linear regression? So, the cause and effect relationship that is given by the linear regression. So, the independent variables are the cause and the dependent variables are the effect. So, the independent variables are nothing but our inputs, and the dependent variables are the output. Okay, so what is the cause and effect relationship that is given by the linear regression, and that can be shown in a graphical manner, the trends which are required for the various purpose. Okay, so that is important regarding the linear regression. That is the mathematical approach basically, and the dependent variable, if it is a y, it has a linear relationship between the independent variable, that is the input x. So we can have a various plots, scatter plot, residual plot, various plot we can draw using a Python. So the least square regression line, it has a basic equation, that is a y is equal to b naught plus b1x. This equation can be implemented to get a coefficients like a b0 and b1 that can be determined here. Okay. So basically in a statistic, we can find out that values of a b0, b1, these are the coefficients and which can be determined using the regression analysis. So the coefficient basically that ranges from the 0 to 1, and the r square of the 0 means the dependent variable cannot be predicted, and from the independent variable, if the r square that is 1, it means the dependent variable can be predicted from the predicted without error from the independent variable. And in the third case, when the r square it is between the 0 and 1, it will represent that the extent to which the dependent variable is predictable on the independent variable. Means if the r square is of 0.10, means the 10% of the variance or the error in the y is predictable from the independent variable x. Similarly, if the r square is 0.20, in that case the 20% that dependent variable is predictable, and so on. So this is the formula to get the prediction and the coefficients about the linear regression model. So in this way, we are going to implement this linear regression model. We have a specific database here. We are using this database to get a mean, and then using this mean, we are getting the coefficient, this b0, b1, and so on. Okay. So we'll see this practical implementation in a Python now. Okay. So I'm sharing my screen of the Jupyter lab now. See next, this is our Jupyter lab homepage. Now we have to go to the Python file. So this is my linear regression Python file. You can write down this code in the new script also. So that's it. First of all, I have to import some libraries for the numerical Python. I have to import the numerical Python NumPy, and for reading the various data sets, we need to import the pandas library. Okay, we'll run this one. And the next thing which is important, that is the scikit-learn library, because the linear model, linear regression model, that is included in the scikit-learn library. So the next thing is to import our data set. We have uploaded one data set that is of the retail data here, that should be in a CSV file format. Okay, then we have to import this one. Okay, I have imported that, and now we have to check whether our database is uploaded or not. Using this syntax dataset.head function, it will show us the various rows and columns of the particular database. Basically, by default, it will show the 5 rows, but if you give the various values, it will show the rows depending upon that. I have entered the 10 value, so it will show that 0 to 9, means 10 columns, 10 rows it will show. So the next part of the Python code of the linear regression is the independent variables array and the dependent variables array. So we should read the database first of all, and we should know the database, what the actually parameters are given in the database, and what the output that we require, that we should know. So basically, this is the supervised machine learning type. So we need to know the independent variables and the dependent variables. Okay, so independent variables are the inputs, and these are the useful to find out the output, means dependent variables. Here the total amount, this one last column, that is the dependent variable. This is the column number 12, its location, and then it depends upon the various values like quantity, rate, then the tax amount, the column number 7, 8 and 12. These are the independent variables, these are the inputs. Okay, so same we have to show here, that is the creating the array of independent variables. So here the syntax is x for the input equal to dataset.ilog 7, 8, 12. So these are the column location for the input variables. So I will execute this. Okay, next is the dependent variable, where our dependent variable is present. It is in the 13 number column. So the same in the syntax. So I is equal to dataset.ilog 13 dot values. Okay, so it will show the various values in the output column. Next thing is to split the data for training and testing purpose. Generally, we are using the 70% data for the training and the 30% data for the testing purpose. So the next part is to split the data. Whatever the data set we have, that should be splitted in a training and testing two parts. So we have tested, we have splitted the data in a training and tested part. Next step is to have the linear regression model. We are going to assign the linear regression model to the variable model. Okay, already the variable model is created, that is the independent model and dependent model. Now we are going to assign the linear regression model using the scikit-learn library. Okay, so this is already the class of linear regression is created there, and now we are fitting the independent variables to the dependent variables. And finally, now we need to find out the coefficient and the intercepts and various mathematical terms in the linear regression. Okay, what the important things are? Coefficients. For that, we have to print the model.coefficient, model.intercept. It will give intercepts. Okay, similarly, residues will be also determined using this particular algorithm. Okay, in this way the coefficients and intercepts are determined. Similarly, the predicted values can also be shown with the various threshold values. Okay, so these are the predicted values for the next 5 columns, and the mean square error can also be determined, which is important to predict the outputs depending upon the independent variables. So this is the mean square error. So in this way, we have implemented the linear regression model in the machine learning using various databases.